Hello everyone and welcome back to my channel. In this video, I'm going to talk about how to do the pressure drop calcs for a duct system. If you are ready, let's begin. Generally, in the duct pressure drop calcs, we have to have two parameters. One of them is the static pressure, the other one is the dynamic pressure. So for the static pressure, we can go with a straight duct. But for the dynamic pressure, it does include the fittings. It does include the dampers, whatever you have in the system that is going to change the velocity. So for the static pressure, again, if you have a straight duct, it's going to create the static pressure. I'm going to talk about an example here. For example, we have 5,000 CFM. And if you want to go with a low pressure system that we did in the previous example, you can look at that video if you have not checked that already. Let's say we want to size this ductwork based on 5,000 CFM and low pressure system. Your size is going to be about 26 inch by 24 inch. And based on this duct, your pressure drop is about 0.092 inch of water gauge per 100 feet. So if I get this number, it should be done, because this number times the length of this straight duct divided by 100 feet gives you the static pressure. So for example, if you have 20 feet of this ductwork, again, it's very easy. This number times 20, the length of the ductwork, divided by 100. This number is going to be your static pressure. But for the dynamic pressure, we got to look at other parameters. So for example, here we have a formula. The TP is going to be the total pressure, or we can call it dynamic pressure also, which is totally different from the static pressure. The C is going to be the dynamic pressure coefficient. How do we get this number? We got to obtain these numbers from some tables. You can find this number from SMACNA tables or from ASHRAE tables. And the last one, the VP, is going to be the velocity pressure of the system. So we have an example here. Let's say we have an exhaust fan, like a asymmetric diffuser at fan outlet. We want to see how much pressure drop we are going to have here. Again, this is not like a static pressure. Why? Because this is not like a straight duct. This is just a piece of ductwork at the fan outlet, which can cause dynamic pressure because we are changing the velocity pressure of the system. Again, we want to see how much pressure do we have here. This is my velocity at the outlet, and the theta and the ratio of the ductwork is 1.5. Again, this table comes from SMACNA tables. If I want to get the C factor, you see, the C factor is here. If I want to get the C factor from this table, I need two factors. One is the theta. Theta is 30 angle based on the example we have here. And the ratio of the side of the ductwork is 1.5. So easily I can get the C factor based on theta 30 and 1.5 for the ratio. The C factor is going to be 0.63 for us. And when I go back to the same formula for the total pressure, I can calculate the VP and call it a day. Again, for the velocity pressure, this is the formula in imperial. If you want to go with metric, the formula is a little different. This is my velocity divided by 4005, and I get 0.2 inch of water gauge for the velocity pressure. So now we have the two numbers, the C factor and the velocity pressure. 0.63 times 0.2. This number is going to be the total pressure or the dynamic pressure of this piece of ductwork, or let's say like a diffuser. And if we have the other components for the static pressure in the system, I can add the static pressure to the dynamic pressure, and that's going to be the total pressure of the system. So again, static pressure is very easy to calculate. For the dynamic pressure, you got to calculate more steps and get the C factor from some tables. And in the next videos, I'm going to talk about more examples for the dynamic pressures because it's a little confusing to some people. But please like and share the videos with your friends. This is going to help us to grow the channel.